Welcome back to the deep dive. So, you've probably seen this if you've ever walked through a modern factory or
hmm
maybe an automated warehouse.
Oh, yeah. The big cages, the yellow fences around the robots.
Exactly, the fences, the panels, and I think we
Yeah.
tend to just overlook them, right? We see them as just static structures.
Yeah, almost like part of the furniture.
Mhm.
But there's so much more than that.
That's it. That's where some of the most critical industrial innovation is actually happening. So today, we're doing a deep dive into the world of custom machine guarding.
And it's uh it's a field that's way more complex than most people think. I mean,
Yeah.
when you look at the source material, it's clear we are so far past the era of just, chain link fences.
Right.
Modern machine guarding is a whole engineered strategy. It's all about minimizing risk from the really fundamental dangers on a factory floor. We're talking relentless moving parts, catastrophic pinch points.
And those massive high hazard operations, it makes sense. So we're moving beyond just like blocking something off to true risk mitigation.
It's-
But why the big focus on custom guarding? What makes that so important for this deep dive?
The core idea is tailoring. That's the whole point. We're talking about solutions that are meticulously designed to fit your specific machine, your unique process, and your exact workflow.
So not a one-size-fits-all solution.
Not at all. This conversation moves way beyond just fixed barriers. We're getting into modular systems, high-tech enclosures, and this is critical interlock doors, embedded safety controls, and designs that still give an operator ergonomic access. It's all about integration, not just installation.
Okay, let's unpack that then, this idea of tailoring. If the solutions are custom, the hazards they're protecting against must be really specific. So
hmm
what are the main physical dangers these guards are built to handle? How do we even start to categorize them?
We can start by looking at it based on location,
Mhm.
proximity to the danger. The sources are pretty clear on this, distinguishing between two fundamental approaches based on where the risk actually is.
Okay, so let's start with the most immediate area, the danger zone right up close.
That would be what we call machine guards, or maybe more specifically, point guarding.
Point guarding.
Yeah, think of these as very localized shields. Their job is compact, it's primary, and it's to protect operators from that immediate danger zone, right where the work is happening.
So like the actual cutting tool or a rotating shaft.
Exactly. Or where two conveyor belts meet. If you've ever had that nightmare scenario of your hand being pulled into a machine, this is the guard that's designed specifically to prevent that.
Okay, so that's point guarding. It's focused on the direct interface, the immediate threat. What's the counterpoint to that? What about the broader space?
Right, that's where perimeter safety guarding comes in. These are the bigger, more durable barriers. They're the ones that define the structured, safe walkways and control every access point around a larger piece of equipment, or like a fully automated machine cell.
Ah, I see. So point guarding handles the operation risk, but perimeter guarding manages the environmental risk.
You've got it. One physically protects you from the machine's action. The other defines the safe zones and the absolute do not enter zones on the factory floor.
I think that's a really essential distinction for you to grasp. Point guarding stops you from touching the danger, while perimeter guarding controls the whole volume of space around that danger.
Precisely. And what really stood out to me when I was going through the material was this shift. It's not enough anymore to just have a passive fence. It just isn't. These custom systems are all about integrating safety controls and engineered panels.
So the barrier might stop you, but there's something else going on.
Yeah, the interlocked door and the embedded safety controls. That's what's communicating instantly with the machine's PLC, its brain.
So how does that integration work in the real world? What's the actual difference between just a simple gate and a proper interlocked door?
A simple gate is just a physical deterrent. That's
Right.
it. An interlocked door is a critical safety component. If an operator opens that door while the machine is mid-cycle,
The whole thing shuts down.
the safety controls immediately tell the machine to initiate a safe stop. And not only that, but the best systems often require a two-hand reset outside the perimeter after the door is closed and locked.
Oh, interesting. Why is that?
It proves the operator is clear of the risk area and is ready for a restart. It ties safety directly into the operational sequence. It just makes the whole system smarter and, inherently safer.
That immediately makes it so clear why customization isn't a luxury. It's an absolute necessity when you're trying to integrate physical barriers with these complex digital controls.
It makes safety part of the process itself, not just an add-on.
Let's scale up then. Let's talk about machines where the forces involved are just immense. I'm not talking about simple automation anymore. I mean, crushing, pressing, stamping operations.
Mm.
It's fascinating how the guarding has to scale up for those applications where the potential energy is truly catastrophic.
And that gets us into the really specialized stuff, particularly stamping and punch press guards. These machines operate with tons of force, literally tons. So the risk profile expands way beyond just a simple pinch point.
Okay, so what are the major threats that these guards have to contain?
There are three, really. First, the obvious one,
Mm.
the heavy pinch points, where the tooling actually meets the material.
Right.
Second, and this is much more violent, are ejection hazards. If a workpiece is loaded wrong or if the material fails under that immense pressure, you can have pieces of metal launched across the floor like shrapnel. I mean, at incredible velocity.
Wow, so the guard has to contain that kinetic energy.
It has to. And the third critical danger in those high-force presses,
What's that?
tooling impact zones. If a die or a punch breaks,
Yeah.
and it happens under that kind of extreme repeated stress, the debris, the broken machine parts, they're highly destructive. The guards for these environments can't be flimsy. They're designed as heavy-duty shields, often with polycarbonate windows set in these heavy steel frames, specifically to absorb and redirect that kind of explosive force.
And speaking of absorbing force, that kind of environment, it demands a certain material response, doesn't it? We are definitely not talking about standard aluminum frames here.
Absolutely not. No way. When the guard itself is going to be subjected to routine physical stress or heat or heavy impacts, think about constant forklift traffic nearby or shielding a high-temperature casting process. You need something really rugged.
So what's the solution?
That's the domain of fabricated metal machine guards. These are custom, high-strength metal guards, usually heavy-gauge steel, built specifically to just shrug off abuse that would dent or warp or completely destroy softer modular materials. They're basically the heavy-duty tanks of the guarding world, engineered for maximum life in the absolute nastiest industrial environments.
This is where it gets really interesting for me because guarding isn't just about stopping physical contact with a part or containing an impact. It's more and more about containing the environment a machine creates. The hazard isn't always the mechanism.
That is such a crucial leap in industrial safety philosophy. It's true, we often focus only on the mechanical trauma, but the byproducts of a process can be just as insidious, just as damaging over the long term. And that's why these custom guarding solutions are extending so deeply into environmental control.
Okay, so give us the rundown. What are the key environmental risks and what are their custom solutions? Let's start with the invisible one we all know, noise.
For that, we have industrial sound enclosures. The benefit here is, well, it's straightforward, but it's life-changing. These are highly effective noise reduction enclosures that completely isolate loud machinery.
And that's a huge deal for worker health.
A massive deal.
Yeah.
Constant, high-level industrial noise, anything over 85 decibels, causes permanent hearing loss. It contributes to fatigue, to stress. We saw sources that detailed cases where a custom sound enclosure took a 105 dB operation all the way down to 80 dB.
That's the difference between mandatory constant ear protection and an environment where you can actually talk to someone safely.
An incredible difference. It changes everything about working on that floor. Then you have airborne contaminants.
Like dust.
Right, and for that you have dust containment systems. These enclosures are designed to be highly effective at protecting both the workers and the surrounding equipment. They capture airborne debris, specific process contaminants. Think about facilities that do a lot of grinding or fine powder handling or work with composites.
You have to contain that.
You have to contain that particulate matter. It's critical not just for lung health, but also to stop that fine dust from getting into sensitive control systems or contaminating other products down the line.
And then the most volatile byproduct of all, chemicals.
For severe chemical risk, we use HAZChem containment walls. These are durable, resistant walls built specifically to protect workers from things like severe chemical splashes, fumes, hazardous processes that involve solvents or highly corrosive agents.
And the challenge there is different, I imagine.
Yeah, the engineering challenge is all about separation and material choice. These things have to contain dangerous liquids or vapors, make sure they cannot cross into the operator or pedestrian area. So you're often looking at non-porous, chemically inert materials.
So if we connect this all back to the bigger picture, these specialized systems, they're acknowledging that the hazard isn't always the physical machine part. It's the process's exhaust, right? The noise, the dust, the corrosive vapors, that really expands the whole definition of what industrial safety is.
And that expansion demands customization. You just can't use a standard steel cage to protect against acid fumes. It won't work.
Let's shift gears just a little bit and focus on a sector where customization meets really extreme regulation: food processing. You can't just install any old metal frame or plastic panel in a facility where consumables are being handled.
That's absolutely right. The unique constraints there, I mean, hygiene, regulatory compliance, you're thinking HACCP and FDA guidelines, they radically change the guarding requirements. The sources we looked at detail very specific needs for machine guards for food processing that go way beyond just mechanical safety.
Okay, so what are the specific criteria that make this so challenging?
Well, material choice is paramount. Standard carbon steel, it's out. You have to use FDA-approved materials, which is most often specific grades of stainless steel, and it has to be finished in a very particular way. But critically, the construction itself must be explicitly washed down safe.
Explain that engineering challenge of being washed down safe. It sounds simple, but I'm guessing it's anything but.
It means the guard has to be designed without any features that could possibly harbor bacteria or mold.
So no little crevices, no flat surfaces.
Exactly. You have to avoid internal crevices, flat horizontal surfaces where water can pool, any inaccessible corners. Everything must be smooth, sloped, and totally accessible for high pressure, high temperature chemical cleaning. That's the washdown process. And that often means using exposed, easily disassembled hardware instead of sealed internal mechanisms.
So you're balancing the physics of preventing an injury with the chemistry and biology of sanitation. Doesn't that clash with the need for robust protection? I mean, if you need rapid access for cleaning, how do you maintain that rigid safety interlocking?
That is the core tension in food processing safety. And it's exactly why customization is non-negotiable. You need safety interlocking systems that are robust enough to hold up against high-pressure water and corrosive cleaning chemicals, but that also allow for quick, tool-free disassembly for the sanitation crews.
And I imagine that gets expensive.
It increases the material cost significantly, yeah. Stainless steel and specialized plastic fittings are not cheap. But compliance is everything. If you harbor bacteria, you could shut down the entire line. The custom guard, in this case, is really a public health investment.
That's a fascinating way to look at the ROI of these systems. It's not just about preventing one accident, it's about preventing catastrophic process failure and huge regulatory violations.
Precisely. And it really underscores why this whole range of solutions we've covered, from that compact little point guard to a sprawling perimeter system to the noise-reducing enclosure, it's all built around tailoring the solution to fit the exact operational, environmental, and regulatory needs of that machine in that specific facility.
So what does this all mean for the industrial world looking forward? We've covered an incredible range of solutions, from simple pinch point protection all the way to chemical and acoustic isolation. The key takeaway seems really clear: comprehensive, sustainable safety. It just can't be an off-the-shelf product.
I think the move toward custom guarding, especially incorporating those sophisticated features like interlocked doors and smart safety controls, it reflects a much deeper understanding. True industrial safety requires integrating protection directly into the workflow, into the process design itself.
It's a fundamental shift.
It is. It shifts safety from being just a mechanical barrier that you add on as an afterthought to being an engineered, proactive component of the entire operation.
It's the difference between a Band-Aid and a tailored protective suit. We've looked at preventing harm from motion, from debris and noise, and we just noted the critical need for FDA-approved washdown safeguards in food production because of sanitation. That was all about material choice based on physical and biological exposure.
It was, yeah. Material science is really the hidden hero of custom guarding.
So, here is a provocative thought for you to chew on after this deep dive. If chemical splashes need these highly resistant HazChem walls and food requires washdown safe stainless steel, what about common industrial processes that involve extreme cold, like large cryogenic freezers or specialized LNG transfer systems?
That's a good question.
Does the standard guarding material just shatter under those immense cold pressures? Do the interlocks seize up because of the contraction? That's where the true material science customization for safety begins. Go forth and investigate the world of guarding in sub-zero environments.
An excellent area for further exploration. That would require a deep understanding of thermodynamics and material rigidity at low temperatures.
That's all the time we have for this deep dive. Thank you for joining us.